Welcome to The Click. This is Roots Rules Part 2. The sixth rule, negative radicand and odd degree rule. If the number inside the root is negative and the root has an odd degree, then the result is a real number. So let's say that I have an odd root or an odd degree and my radicand is a negative number. At that time, the answer will be a real number. Okay, so what does this mean? It basically means that cube roots or odd roots basically can handle negative numbers, but even degrees cannot, or even indexes cannot, because, the even index and the negative radicand don't match with each other. But odd degrees and negative numbers do, or negative radicands do. So that is why the result is a real number. Let's experiment this with an example. For example, I have the third root of minus 8. So my degree is odd, my radicand is a negative number, so I know that the answer is a real number. What does this mean? It means that the result is minus 2. What happened? Let me show you. So if I have minus 2 times minus 2 times minus 2, basically minus 2 to the power of 3, which is our degree, it equals minus 8, right? Because minus times minus plus times minus minus. So that is why, the sign will keep being negative. And that is why we say that the answer for this type of a question or this type of an operation is always a real number. Okay, going for root and root rule, which is the seventh one, we say that when a root is placed inside another root, it becomes a single root with multiplied indices, or with multiplied indexes, or with multiplied degrees. So if I have, for example, the end root of the mth root of a, I can simplify it and write it as the n times mth root of a. What does this mean? Okay. Think of roots like steps of undoing multiplication. So for example, when I have the second root of 4, I know that the result is 2. So I know that, when 2 is multiplied by itself 2 times, it equals 4, right? So that is a multiplication. But roots are undoing multiplication, with the result and with the power. So a root means how many times did we multiply to get this number? And that number is our radicand, right? So now, if you have a root inside another root, right? One root inside another root, it means undoing multiplication twice. Okay, so because roots are basically for undoing multiplication, and when we have 2 roots, it means 2 times undoing multiplication. So instead of doing it 2 times, we do it at 1 time, and we combine the degrees. That is why this works. So for example, I have the second root of the third root of 4, for example. This is going to be the same as the sixth root of 4. But also we have a part 2 of the seventh rule, which is root and root part 2. If you have multiple roots multiplied together, okay, you can combine them into one root by multiplying the indices. This is the same definition, right? But the point is that the formula is different. In root and root rule part 1, our leftmost roots did not have any radicands. If we have root and root, but our roots, all of them have radicands, at that time what should we do? We still multiply the roots, or we still multiply the degrees, but the thing that we need to consider is to put the degrees in front of a radicand as its power in multiplication. Okay, so what do I mean by this? For example, I have the nth root of b, the mth root of a, and the pth root of c. This means n times m times p as the degree, right? Okay, it's okay. But b needs to be to the power of m times p, because let's see, m and p both are degrees of roots and they are in front of b. But for a, it's not like that, a only has p in front of it. So that is why, we only put p as the power of a. But for c, as it doesn't have any, root in front of it, or any degree of the root in front of it, so it doesn't have any power. The power of it is 1. So yeah, this is the second formula. It's a little bit complicated, but you need to take a screenshot. Let me erase this. Now let's do an example. For example, I have the third root of 2 to the power of 2 times the fourth root of 3. Okay, so we said that we should multiply the degrees first of all. So through 3 times 4, it is going to be 12. 12th root of 2 to the power of 2, because it had the power of 2 beforehand, times 4, because 4 is a degree of the root in front of it. Okay, so 2 times 4 times 3. Do you know why? Because 3 is in here, it's a radicon, but it doesn't have any roots or any powers in front of it. So yeah, this is how we do the operation. So it basically will equal the 12th root of 2 to the power of 8 times 3. Okay, let's do another example. So I have the second root of 3, the third root of 3, the second root of 3. Okay, let's do it. So first of all, let's multiply the degrees. So 3 times 2, 6. 6 times 2, it's going to be 12. And then inside the root, we are going to have 3 to the power of 3 times 2, because 3 and 2 are both the degrees that are in front of the first 3, right? Okay, so 3 to the power of 3 times 2 times 3 to the power of 2 times 3. And the result will be the 12th root of 3 to the power of 6 times 3 to the power of 2 times 3. And you can simplify this as well. Okay, this was the 7th rule, the long one. Let's go for the 8th rule. Radicals multiplication with the same degree. If the radicals have the same degrees, multiply them using this formula. So they have the same degrees, we only multiply them and we keep the degree. That's it. So for example, I have the second root of 2 times the second root of 4. This is going to be the second root of 2 times 4, which equals the second root of 8. Okay, the 9th rule, radicals multiplication with different degrees this time. If the radicals have different degrees, multiply them using this formula. So I have the nth root of A times the mth root of B. I will multiply the degrees, and there is another step, okay? Please pay attention. I will multiply the degrees, but at the same time, I will put the opposite roots degrees as the radicon's power, okay? So the power of A will be m, and the power of B will be n, okay? And this is the exact formula, degrees multiplication, and also A to the power of m and B to the power of n. Please pay attention that the radicons don't go to the power of their own root's degree. They go to the power of the opposite root's degree, okay? So let's do an example. For example, I have the second root of 4 times the third root of 8, okay? This will be the same as the 2 times 3, which is 6, right? The sixth root of 4 to the power of 3 times 8 to the power of 2, which will equal the sixth root of 64 times 64. As 4 to the power of 3 and 8 to the power of 2 both equal 64. And this is our answer, everyone. We can write it as the sixth root of 64 to the power of 2. And this is our answer. We are done with today's lesson. I hope you got it. And if you've got any question, feel free to ask in our Telegram group. And the link is below in the description part. Thank you. sources page.